Hello, a pleasant day to you, my dear student. In this video, we will be talking about linear equations in one variable, which was taken from the module titled Linear Equations in One Variable by Josephine G. Capones and Mary Grace S. Crisostomo. At the end of this video, you're expected to differentiate algebraic expression, equations, and inequalities, give the additive and multiplicative inverses of numbers, state the addition and multiplication properties of equality, find the solution of linear equations in one variable, and solve problems involving equations in one variable. But before we proceed to our lesson, let us recall first the different terms related to algebra. We have here the number 3. Now in algebra, what do we call a number such as 3? Very good. It's a constant. How about a letter such as X? You're right. It's a variable. Now, a number alone or a variable alone or a combination of a number and a variable, what do we call them? You're right, it's a term. Now, how about if the term is followed by an addition symbol and a number? Correct. It's an algebraic expression. And all you are also right. It's a polynomial because a polynomial is an algebraic expression. Now, what if after that algebraic expression is an equal sign followed by a polynomial? What is formed now? You're right. We now call this an equation because of the equal sign. Now, what if we remove that equal sign and change it into greater than symbol? Excellent. This is now called an inequality. So to start our lesson on linear equations in one variable, let us have the differences among algebraic expression, equation, and inequality. So when we say algebraic expression, it's just a phrase. So when we're going to translate an algebraic expression in words, we only form a phrase. Cannot be solved, but it can be simplified through evaluation or performing the fundamental operations. It has no relation symbol, therefore it's one-sided. An example here is 5x minus 8. Then for equation and inequality, they are both sentences and they can be solved. But the difference between equation and inequality is the relation symbol. Because for equation, we only have the equal sign. For inequality, we can have not equal to, less than, greater than, less than or equal to, or greater than or equal to. And they are both two-sided. They have the left and the right side. An example for equation is 2x plus 3 equals 15. And for inequality, we have 4x plus 1 is greater than or equal to 5. Next, we have solution. What do we mean when we say solution of a linear equation or solution of an equation or inequality? So it's a replacement value of the variable that will make the equation or inequality true? What should be the value of that variable that will make the equation or inequality true? Say for example, we have 6 minus 2m equals negative 2. Let us determine if the number 4 is a solution of the given equation. So to do that, we have to substitute the value of m, which is 4, to the given equation. And we must arrive at a true statement. Let us see. 6 minus 2 times the value of m, which is 4, equals negative 2. 6 minus 2 times 4, that's 8, equals negative 2. Simplifying 6 minus 8, we have negative 2 equals negative 2. Therefore, 4 is a solution of the given equation. Another example, 2x minus 2 is greater than 4. Let us determine if 3 is a solution of the given inequality. So we have 2 times the value of x, which is 3, minus 2 is greater than 4. Let us simplify the left side of the equation first. 2 times 3, that's 6, minus 2 is 4. Now, is 4 greater than 4? Of course, it's a false statement because 4 is not greater than 4. They are equal. Therefore, 3 is not a solution of the given inequality. Now, there are two properties of linear equations in one variable. First, it has a degree of 1. If you can still remember, when we say degree, it's the highest exponent of the variable, or the highest sum of the variables if there are two or more variables in a term. And second, it has only one variable and one solution. Now, since there is only one variable, then that variable must have an exponent of 1. Examples, 3x plus 7 equals 7. Okay, we only have one variable and that's x. And its exponent is 1. Also with y equals 10. We only have the variable y with an exponent of 1. For a minus 5 equals 2, we have one variable, that's a, with an exponent of 1. For the last example, we have 2m minus 3 equals 6 plus 8m. We have two variables, one on the left side and one on the right side, but they are the same. Therefore, if we find the degree of the given equation, it's still 1. Both variables have an exponent of 1. Next, we have solving linear equations in one variable, which means finding the value of the unknown or finding the value of the variable. In doing this, we can use the addition property of equality, or the APE, which states that if A equals B, then A plus C equals B plus C. So if we add a value to the left side of the equation, then you must also add same value or number to the right side of the equation. Now, in using the APE to solve linear equations in one variable, you must familiarize yourselves with what we call the additive inverse of a number. So it's a number that you add to another number to get 0. And how are you going to find for that additive inverse? So say for example, if we have 7, its additive inverse is simply negative 7. You just have to change the sign. So if that's negative 3, then its additive inverse is positive 3. If it's positive 5, then its additive inverse is negative 5. And so on. Let us have examples. First, x plus 7 equals 10. We have to solve for x. So to do that, we have to isolate the variable x on one side of the equation. That means we have to get rid of this positive 7. So to do that, we have to add its additive inverse. So we have x plus 7 plus the additive inverse of positive 7, which is negative 7, equals 10 plus adding the same, we have negative 7. 7 plus negative 7 is 0, so we have x plus 0 now on the left side. And on the right side, we have 10 plus negative 7, that is 3. Any number plus 0 is the same as the number itself, so we have x equals 3. Let us check. X plus 7 equals 10. That's the given equation. By substitution, we have 3 plus 7 equals 10. Therefore, 10 equals 10. So we arrived at a true statement, which means 3 is a solution of the given equation. Another example. Negative 15 equals negative 4 plus m. M is on the right side of the equation. So we have to isolate m at the right side. So to do that, we have to remove negative 4 by adding its additive inverse, which is positive 4. So adding positive 4 to both sides of the equation, we now have this one. Simplifying the left side, negative 15 plus 4, that's negative 11 equals m plus the sum of negative 4 and 4, that's 0. Or if you don't want to add 0, you can do that because you can cancel negative 4 and positive 4. So we have negative 11 equals m. Let us check. Negative 15 equals negative 4 plus m. By substituting negative 11 to the variable m, we now have negative 15 equals negative 4 plus negative 11. Adding negative 4 and negative 11, we have negative 15. Therefore, negative 15 equals negative 15, which is a true statement, which means negative 11 is a solution of the equation negative 15 equals negative 4 plus m. Another example, 3m minus 5 equals 2m plus 12. Now, we have to combine those same terms on one side of the equation. So first, we have to get rid of this negative 5 by adding its additive inverse, which is positive 5. So adding 5 to both sides of the equation, we now have 3m, cancel negative 5 plus 5, then bring down 2m plus 12 plus 5 is 17. Now, since we want to look for the variable m, then we have to combine those terms with the variable m on one side of the equation. So to remove 2m on the right side, we have to add its additive inverse, which is negative 2m to both sides of the equation. So we now have 3m plus negative 2m. That's 3 minus 2 is 1 times m. We have m. Take note, when a term has a numerical coefficient of 1, you should omit that numerical coefficient because a variable alone means it has a numerical coefficient of 1. Then cancel 2m plus negative 2m. So we have m equals 17. Let us check. 3m minus 5 equals 2m plus 12. Substituting 17 to the variable m, we have 3 times 17, that's 51, minus 5 is 46. For the right side, we have 2 times 17, that's 34, plus 12 is 46. So it's a true statement. Therefore, 17 is a solution of the given equation. Now, aside from adding the additive inverse, we can also use what we call transpose. When we say transpose, you transfer a term to the other side of the equation. And in doing that, you must change the sign. So say for example, for the example x plus 7 equals 10, since we are looking for the variable x and we want to get rid of this positive 7, then we can do that on the left side. So removing positive 7, we only have now the variable x. But since we remove that positive 7 on the left side, it must go to the right side but with a different sign. So from positive 7, we now have negative 7. So simplifying, we have 10 minus 7, that's 3. Therefore, x equals 3. Another example. Negative 15 equals negative 4 plus m. This time, we have to get rid of this negative 4. So to do that, we have to transpose it on the left side of the equation. So we have negative 15. From negative 4, it now becomes positive 4 equals m. Simplifying negative 15 plus 4, that's negative 11 equals m. Therefore, negative 11 is a solution of the given equation. Another example, 3m minus 5 equals 2m plus 12. So since both sides of the equation have the variable m and both have constant, we have to transpose two terms of the equation. First, we have to transpose negative 5 to the right side. So it now becomes 3m equals 2m plus 12 plus 5. So that's 3m equals 2m plus 17. Now, we also have to transpose 2m. So from positive 2m, when we transpose, we now have 3m minus 2m equals 17. And 3m minus 2m, that is m. Therefore, m equals 17. Now, aside from the APE, we can also solve linear equations in one variable using the multiplication property of equality or the MPE. It states that if A equals B, then AC equals BC, or multiplying a number or any value to the left side of the equation, it should also be done to the right side of the equation. Now, in using the MPE, you should familiarize yourselves in finding the multiplicative inverse of a number. When we say multiplicative inverse, it's a number multiplied to another number to get 1. Let us have examples. 7. Its multiplicative inverse is 1 over 7. For negative 3, its multiplicative inverse is negative 1/3. So if you're going to observe, if the given number is positive, its multiplicative inverse should also be positive. If it's negative, then it should also be a negative multiplicative inverse. And it is simply the reciprocal When we see reciprocal, you just have to interchange the numerator and the denominator. So for negative 1 over 5, its multiplicative inverse is negative 5 over 1 or simply negative 5. For negative 5 over 8, we have negative 8 over 5. The numerator becomes the denominator and the denominator becomes the numerator. And the signs does not change. Let us have examples. First, 2x equals 10. So to solve for x, we have to get rid of 2. Take note, when we have a number and a variable together, the operation between them is multiplication. So to remove 2, we have to multiply both sides of the equation by its multiplicative inverse, which is 1/2. So we have 1 times 2x, that's 2x over 2. Then for the right side, we have 10 times 1 is 10 over 2. Or if you had observed, it is simply dividing both sides by 2. 2 divided by 2 is 1 times x is x, and 10 divided by 2 is 5. Therefore, x equals 5. We have 2x equals 10. By substitution, we have 2 times 5, that's 10, equals 10. So we arrived at a true statement. Therefore, 5 is a solution of 2x equals 10. Another example, 28 equals negative y. Our target here is to remove that negative sign and to change any number to positive. We can multiply or divide that number by negative 1. Let us have multiplication of both sides by negative 1. So we have negative 1 times 28, that's negative 28, and negative y times negative 1 is y. Therefore, y equals negative 28. Another example, negative 2/3 y equals 3. This time, the numerical coefficient of y is a fraction. It's negative 2/3. So we have to look for its multiplicative inverse, and that's negative 3 over 2. So multiplying negative 3 over 2 to both sides of the equation, we have the number times the multiplicative inverse, that is 1 times y, so we have y. And 3 times negative 3, that's negative 9 over 2. Take note, if the answer is a fraction, you do not have to change it into a decimal. You just have to make sure it's in its lowest term. Therefore, y equals negative 9 over 2. And that's the use of MPE. Next, we have using both the addition and multiplication property of equality. Example, 2x plus 7 equals negative 5. If you use both the APE and the MPE, you must start from using the APE. In isolating x here, we have to get rid of positive 7 first before 2. So to do that, we have to transpose positive 7 to the right side of the equation. So we now have 2x equals negative 5 minus 7. So we have 2x equals, combine negative 5 and negative 7, that's negative 12. Divide both sides by 2 to solve for x. So we have x because 2 divided by 2 is 1 times x is x. And negative 12 divided by 2 is negative 6. Or we simply have to cancel 2 here. So we have x equals negative 6. 2x plus 7 equals negative 5. That's the given equation. By substituting negative 6 to the variable x, we now have 2 times negative 6, that's negative 12, plus 7 is negative 5, which is equal to negative 5. So it's a true statement. Therefore, negative 6 is a solution of the given equation. Next example, we have 5y equals negative 55 plus 10y. So in here, what we're going to transpose is positive 10y. So we have from positive 10y to the left side, we now have negative 10y. 5y minus 10y, that's negative 5y equals negative 55. Now, since we have a numerical coefficient of y, we have to divide both sides by the numerical coefficient, which is negative 5. Cancel negative 5. So we have y equals negative 55 divided by negative 5. That's positive 11. Therefore, 11 is the solution of the given equation. Another example. Negative 5x plus 23 equals 10x minus 7. To solve for this, in this example, we have to transpose two terms. One is positive 23 and the other one is positive 10x. And we can do that at the same time. So we have negative 5x. Now when we transpose positive 10x, it now becomes negative 10x. Then copy negative 7. For positive 23, we now have negative 23. Simplifying, we have negative 5x minus 10x, that's negative 15x. Negative 7 minus 23, that's negative 30. And dividing both sides by negative 50, we now have x equals 2. Therefore, the solution of the given equation is 2. Another example. 2x plus 4 over 4 equals 13 over 2. There are two ways on how to solve this given equation. First is using the cross multiplication. So when we cross multiply, we now have 2x plus 4 times 2 or 2 times 2x plus 4. This one. For the other one, we have 4 times 13 or 13 times 4. Simplifying the product. Simplifying now the new equation, we have to use the distributive property on the left side. So that's 2 times 2x, it's 4x. 2 times 4, that's positive 8. And for the right side, we have 4 times 13, that's 52. Next, since we are looking for x, we have to get rid of positive 8 and 4. Starting from APE, transpose positive 8 to the right side. So we have 4x equals 52 minus 8. And 52 minus 8, that is 44. Then, to get rid of 4, we have to divide both sides by 4. So we have x equals 11. Another solution is multiplying both sides of the equation by the LCD. Since we have the denominators 4 and 2, the LCD is 4. So when we multiply 4 to both sides of the equation, we cancel 4. So we have 2x plus 4. And then on the right side, we have cancel 2 and 4. 2 divided by 2 is 1. 4 divided by 2 is 2. So we now have 13 times 2. 13 times 2, that's 26. And then equal to 2x plus 4. Transpose positive 4 to the right side, so it now becomes negative 4. 26 minus 4 is 22. Divide both sides by 2, so we have x equals 11. So still, we arrived at the same answers. So we're done with solving linear equations in one variable. Now, let us apply what we have learned in solving in real life situations. So let us have now applications of linear equations in one variable through problem solving. First, age problems. Example, Dana is twice as old as Lorraine. If the sum of their ages is 72, how old are they? So first, to solve each problems, we have to let values. But before that, you have to remember that in assigning, assign the last name mentioned as the variable. So in here, if we're going to let a variable, let's say x, then that should be the last name mentioned. So there are two names here, Jana and Lorraine. Jana is the first name mentioned, therefore Lorraine is the last. Therefore, X is the age of Lorraine, and for the age of Jana, since it was stated that it is twice as old as Lorraine, and twice means two times, therefore we have two times the age of Lorraine, so that's 2 times X, or simply 2x. Then for the solution, let us solve first for the age of Lorraine, or the variable x. But for the working equation, we have the sum of their ages is 72. Sum of their ages. So we're going to add their ages, x and 2x. So that's x plus 2x equals 72. Simplifying, we have x plus 2x, that's 3x equals 72. And dividing both sides by 3, so we have x equals 24. So Lorraine is 24 years old. Now, for the age of Jana, we're going to base her age on the age of Lorraine because we have the representation 2x. And since x equals 24, so we have 2 times 24, and that is 48. Therefore, Jana is 48 years old while Lorraine is 24 years old. Another example. Samuel is 6 years older than Joanne. The sum of their ages is 52. How old are Samuel and Joanne? So first, we have to let values for the given. Again, the last name mentioned is Joanne. Therefore, X is the age of Joanne. For Samuel, we have Samuel is 6 years older. Therefore, that's plus 6 years. So x plus 6, that's the age of Samuel. For our working equation, we must base that from the statement, the sum of their ages is 52. So taking the sum of their ages, we have x plus 6, and that is equal to 52. Combining like terms, x plus x, that's 2x plus 6, we have 52. Transpose positive 6 to the right side. So we have 52 minus 6, that's 46. And dividing both sides by 2, so we have x equals 23. Therefore, Joanne is 23 years old. Now, for the age of Samuel, we use the representation x plus 6. Now, since x equals 23, so we have 23 plus 6, that's 29. Another type of problems where solving linear equations in one variable is applied or can be applied is distance problems. We have here the formula D equals RT. For you to remember the formula, it's dirt. D for distance, E for the equal sign, R for the rate, and T for the time. So the rate can be in the following units: kilometer per hour, meter per second, mile per hour, meter per minute, and so on. For time, we have hour, minute, seconds, and so on. D for the distance, we have kilometers, meter, mile, inches, foot, and so on. Let's have examples. First, a cheetah can run at the speed of 100 kilometers per hour. If it runs for 2 hours, what is the distance he can travel at this speed? So using the formula, but before that, we have to identify first the given. We must complete the DRT. R is 100 kilometer per hour, T is 2 hours, and D is the unknown. So for the solution, we have the equation D equals RT. By substitution, R is 100 kilometer per hour and T is 2. So 100 times 2, that's 200. Cancel R, so we have kilometers. That means the cheetah covered a distance of 200 kilometers. Another example. IZ ran for 1 hour this morning. If she covered a distance of 3 kilometers, how fast did she run? Again, let's determine the given. We have the D, the R, and the T. R is the unknown since we were asked on how fast did IZ run. For the distance, we have 3 kilometers, and for the time, we have 1 hour. For the solution, we have the formula D equals RT. By substitution, we have 3 kilometers equals R times 1 hour. Now, we can divide both sides by 1 hour or we can multiply 1 over 1 hour. So, we have R equals 3 kilometer per hour. That means IZ ran at a speed of 3 kilometers per hour. Now, aside from age and distance problems, it can also be applied to number problems. This example, the sum of two numbers is 32. If the bigger number is thrice the smaller number, what are the numbers? In solving number problems, we must also do what we have done in solving age problems, which is letting variables to the given. Now, since there are two numbers and the last mentioned number is the smaller number, therefore it's the variable x. Now, for the bigger number, it says there, it is thrice the smaller number. And thrice means 3 times. So we have 3x. And for our solution, we have the sum of two numbers is 32. Again, sum of two numbers, so that's x plus 3x equals 32. Combining like terms, 3x plus x, that's 4x equals 32. And dividing both sides by 4, we have x equals 8. Now, for the larger number, we have 3x. So, by substitution, we have 3 times 8, and that is 24. Therefore, the smaller number is 8, and the bigger number is 24. Another example. The smaller number is 6 less than the bigger number. If the sum of the two numbers is 60, find the two numbers. So again, we have to let values or variables to the given. We have the last mentioned name is bigger number. Therefore, it's our variable x. Then for our smaller number, it says there, it is 6 less than the bigger number. So that is x minus 6. Then, the sum of the two numbers is 60. Therefore, for our solution, we have the working equation x plus x minus 6. That's the sum of those two numbers is equal to 60. Combining like terms, we have x plus x, that's 2x minus 6 equals 60. Transpose negative 6 to the right side of the equation, we now have positive 6. 2x equals 60 plus 6, that's 66. Divide both sides by 2, so we have x equals 33. Now, for the smaller number, we have x minus 6. By substitution, that's 33 minus 6 is equal to 27. So the smaller number is 27 and the larger number is 33. So that's all for the applications of solving linear equations in one variable. And that ends our discussion. But before we end this video, always remember what we have discussed. First, we had the differences between algebraic expression, equations, and inequalities. For algebraic expression, it's just a phrase. It does not have a relation symbol. For equations and inequalities, they both have two sides and they are both sentences, but they only differ on the relation symbol used. Then we also discussed on linear equations in one variable and its properties. First is it's a linear equation if it has a degree of 1. And the other one is it has only one variable and one solution. Then we also discussed on solving linear equations in one variable, wherein we use the APE, the MPE, and both APE and MPE. But if you use both properties, you have to start with the APE before the MPE. Then last, we had the problem solving involving linear equations in one variable. So we applied the lesson on three main problems. We have age, distance, and number problems. And don't forget the formula for distance. We have the distance equals rate times time. And that ends our video lesson. Thank you all for watching.